So you've probably noticed by now that I like to write things out as I read the question. So a cargo van delivers only 50-pound and 80-pound packages. So we have 50-pound packages, 80-pound packages. For each delivery trip, the van must carry at least 20 packages, and we know it's a combination of, I'm going to use F for 50 and E for 80. So it's a combination of those two kinds of packages. We'll say F of these 50-pound packages, E of these 80-pound packages for 20 packages total. And the total weight cannot exceed 1,500 pounds. So it must be 1,500 pounds or less in weight. Now they want to determine what's the maximum number of 80-pound packages the van can carry per trip. Well, if they have F 50-pound packages and each one weighs 50 pounds, and E 80-pound packages and each one weighs 80 pounds, we have our system of inequalities here. Now, really what you can do, even though it's a system of inequalities, we could use our solve systems program to be able to solve it as if it were with an equal sign instead of inequality symbols. So let's check out what we get here. So we'll go to solve systems, which is program number 4. We'll type in these coefficients, and this gives us what it would be if it were exact. So obviously, you're not going to be able to do fractions here, but if we're trying to figure out the maximum number of 80-pound packages, so let's go ahead and type these in and see what we get. What are these actually equivalent to? So 10 divided by 3, 50 divided by 3, and the 50 divided by 3 is actually the one we're looking at, right? Because that's the y coordinate, the second variable. The second variable for us was E, and that's what we're trying to determine. What's the maximum number of 80-pound packages? So what we're going to do here is really, we've narrowed it down, right? If it's 16.6 repeating, we know it's either going to be 16 or 17, so we could eliminate options A and D. But with questions like this, it can be a little tricky. We don't necessarily want to round with normal rounding conventions to round up to 17 because we need to stay within the constraints given. So let's try each of these two. If E were 16, that would mean that F would have to be at least 4, right? In order to be at least 20 packages. So if we plug in 4 for F in this top equation and 16 for E in the top equation, let's see if we stay under this 1,500 pound limit. So we'll say 50 times 4 plus 80 times 16, and we do stay under the limit. So it seems like 16 is the right answer, so B, but in case you're curious, let's see if instead we had chosen 17. Well, if we plug in 17 for E, that means F is going to have to be 3, right? In order to still satisfy this bottom inequality of being at least 20. And then let's go ahead here, typing in our 17, and notice we exceed that 1,500 pound limit. So it would not be C. The correct answer is B.